First, let's examine the cosmic waiting room where Booster 7 and Ship 25 are waiting to see whether the FAA decides what to do with them. A little restless, Booster 9 decided to add some color to the picture by playfully waving its 4 grid fins. Because as they wait for the all clear, even rockets get bored. Welcome back to another exciting video. Today's video is about Elon Musk finally revealed SpaceX's insane new Raptor engine. Before we start the video, please like, subscribe, and press the bell icon. Why is the most recent Raptor engine from SpaceX considered a revolutionary development for space exploration? Come along on this cosmic adventure with us as we reveal a glimpse of SpaceX's incredible Raptor engine's engineering. Booster 9's grid fins are SpaceX's secret weapon. Unlike the deployable cast titanium fins of the Falcon family, these grid fins are set in situ and meticulously crafted from welded steel, proving that sometimes the devil is in the details. At an incredible 16 feet tall and 8 feet broad, their unwavering construction emphasizes their significance as crucial parts of rockets. These large, unfoldable steel grid fins play a pivotal role in highlighting their immense significance. It becomes problematic to rely only on the reaction control system to stabilize the vehicle and adjust orientation throughout every stage of the descent. In the era of reusable rockets like the Falcon 9 and Starship, this is especially true. Owing to the abrupt and sometimes hazardous variations in velocity and density, these commanding grid fins actively supply the necessary stability. Even more astounding is the fact that their effectiveness is not the only factor. It also talks about the big challenges these fins overcome. Not only are they doing their share, though. Their strong shoulders are bearing the weight of the entire universe. The rocket would have to use more working fluid if RCS was the only attitude control method, which would have resulted in a larger booster. On the other hand, the grid fins offer a revolutionary method of stability. They draw attention to how these probably straightforward components affect rocket engineering as a whole. Aerodynamic control surfaces with low hinge moments are essential for aircraft. It is also necessary for these surfaces to function well across a broad range of Mach values, from supersonic to subsonic. In this case, what is the best option? Let's introduce grid fins, often known as lattice wings or lattice controls. These tiny, unconventional aerodynamic control surfaces are composed of several parts that are firmly attached by a single framework. Each component appears to have rectangular wings, a constant chord, and an aspect ratio that is typically high. Among the many advantages of grid fins are their minimal weight and volume and exceptional aerodynamic performance. Grid fins provide adjustable aerodynamic qualities over a wide range of Mach numbers and deflection angles, and they have small hinge moments. They also offer better roll stability and more yaw stability at high incidence angles. Because of the modest shift in the center of pressure caused by these moments, actuation requires less torque and lighter gear. Because of their compact size and ability to fold down into the fuselage, missiles are simpler to transport or store. Interestingly, the Starship grid fins not only utilize the booster continuously, but they also employ Mechazilla to carefully and safely gather it. Which of these noteworthy benefits is the main disadvantage? One major drawback is the multi-plane construction, which causes extremely high wave drag and insufficient stability and effectiveness at transonic speeds. How did SpaceX solve complex aerodynamic problems and make rocket technical advancements? In order to solve these issues, SpaceX raised the required Mach number. This modification was made to lessen the impact of individual members' shock cones and counteract the stronger bow shock that was occurring upstream. The identical outcome was also obtained by inducing a sweep in every single member. This modification enhanced transonic behavior and reduced the strength of the bow shock wave. For flat grid fins, the leading edge bluntness of individual members and the total surface thickness can be lowered to reduce wave drag efficiently. Parts or members can have multiple profiles, similar to how a chameleon changes color. All profiles, from the simpler hexagonal airfoils to the more complex double wedges and wedges, contribute to reducing drag and increasing efficiency. The problem is that when production prices rise, the use of these profiles may decline. Back at Starbase, two odd sightings occurred when two strapped-down Raptor engine bells, R-14 and R-136, appeared at the building site. Were these Raptor engines standard issue? Not at all. The fact that they were nozzles and combustion chambers points to a possible improvement in the following generation. 31. The lift took off from the upper bay. Now, though SpaceX's exact intentions remain unknown, it is a part of the amazing array of fully stacked starships at Starbase. Cryogenic proof testing for Ship 29 and Booster 10 was successfully finished in the midst of this. Installation of the engine was made possible by this. In order to further improve the dynamic environment of ongoing Starship advancements, Ship 24.2 has sailed into Massey's and is getting ready for upcoming testing. Despite temporarily shelving Starship, SpaceX has officially concluded the third quarter of the year with an astounding 70 flights. This accomplishment exceeds the business's prior record of 61 launches, set in 2022. Since its inception in 2020, SpaceX has completed 26 launches. The company has surpassed the prior year's year-to-date record. Now that this remarkable run has continued for 4 years running, SpaceX is unquestionably in the winner's circle of space exploration. SpaceX was able to considerably boost its launch rates by replacing the outdated Gen 1 satellites with the Gen 2 small Starlink satellites that Starlink introduced. These state-of-the-art substitutes are gradually replacing the over 4-year-old Gen 1 satellites. Just 27 of this year's 70 launches were not Starlink missions. What a fantastic accomplishment the Starlink missions have made. This covers Department of Defense missions, commercial satellite launches, and NASA crewed and cargo flights. Remarkably, most of these 70 launches have been executed by the Falcon 9. Despite being basically a Falcon 9, there has been a noticeable increase in Falcon Heavy flights in 2023, with 2 more first stages mounted to its sides as boosters. Following its first round of commercial launches in 2019, the Falcon Heavy was put into hibernation as a boosters. This lull was broken in late 2022 when the Space Force launched its first mission aboard a Falcon Heavy. Since then, 3 more launches have occurred this year, and NASA's Psyche probe will soon be launched in a 4th rocket. Falcon Heavy is leading SpaceX. Has motivated most of this year's launches. Not only does it tie the record for the 3rd consecutive year, but it's an amazing accomplishment. However, it also places them at the forefront of space exploration. SpaceX has demonstrated its superiority in the sector with 3 crewed space missions in 2023 alone. Interestingly, not a single crewed flight has been completed by their rival Boeing. Not only is 2023 a great year for SpaceX, it's looking like it will be an incredible voyage that breaks all prior records, leaving other companies in awe of SpaceX's unmatched accomplishments far behind. Thanks for watching the video. If you enjoyed it, please like, share, and subscribe to our channel for more exciting content.